So we're going to get another word problem section, and a lot of the word problems that I pick for our class are word problems that you'll probably see again in a calculus class if you take calculus, and you'll solve them with calculus as opposed to with algebra. So as much as anything, I'm just trying to get you prepared for what you're going to see in calculus if you get to take calculus. I will do number 2, and I'll flash number 1 back up. So my problem in number 2, it says an object is fired vertically into the air and it will be at a height h in feet t seconds after launching, determined by the equation h equals 96t minus 16t squared. So what this function does, if you plug a time in for t in seconds, it will tell me how high that object is, whatever the object is being fired vertically in the air. So the h is the height of the object in feet. And the t is the time in seconds. This, whatever this object is, when you fire it into the air, it's going to follow a path that looks like this. It's probably going to start at the ground, it's going to go up, and then it's going to loop back down. The nice thing is the amount of time it takes to get to its high point is going to be equal to the amount of time it takes to get to its low point in some sense. We'll get to that in a second. So first question asks, when will the object have a height of 80 feet? Well, assuming that it actually gets up to 80 feet, what I'm trying to find is a point or 2 points on the graph. If I mark an 80 on the y-axis, because the y-axis is my height, and I go across to the graph, I'm going to probably hit 2 points. Each of the points that I've just put dots by is a point some number, comma 80, and the x's for this graph, the x coordinate of every point is a time. So each of these 2 points has an x coordinate as a time, a y coordinate as a height of 80 feet. So what I'm going to do is I'm going to find these 2 points on the graph by plugging into the equation 80 for h, and I'm going to solve for t, and I'm going to get the 2 times the object is at a height of 80 feet. So I'm going to solve the equation 80 equals 96t minus 16t squared. Because there's a square, I should probably set it equal to 0 and solve either by factoring or the quadratic formula. So I'm going to add 16t squared and minus 96t from both sides, and that's going to get me the 0 that I'm going to need to have on the right-hand side to get this solved by either factoring or the quadratic formula. So I subtracted the 96t, I added 16t squared, and that's going to make the right-hand side 16t squared minus 96t, and that 80 gets a plus sign because it didn't have a sign, it doesn't deserve a minus sign. That's a monstrous problem to solve. Each of the numbers in this problem is divisible by 16, and if a problem has an equal sign and there's a common factor that doesn't have a letter, you could actually divide each number by that common factor to make the problem easier to solve. So that's what I'm going to do to get my part 2a more reasonable to solve. So dividing 16t squared by 16, I get t squared. Dividing negative 96 divided by 16, you can't even see that, I get 6. So dividing that middle term is going to give me a minus 6t. And the last term, dividing 80 by 16, I'm going to get 5. So I can solve the equation t squared minus 6t plus 5 equals to 0. And I'm going to solve this by factoring. Now this is a double minus. My lasts, when I go to factor this, have to multiply to 5 and add to 6, and that's going to be 1 and 5 because 1 times 5 is 5, and 1 plus 5 is 6. Now that I have it set equal to 0 and factored, I set each of the parentheses equal to 0 and solve for t. For the first one, I'm going to add 1 to both sides and get t equal to 1. The second factor, I'm going to add 5 to both sides and get t equal to 5. So the 2 points that I'm calling out here are the points 1, 80, which says at 1 second the object is 80 feet in the air, and 5 comma 80, which says at 5 seconds the object is 80 feet in the air. So my answer to part 2a, the question is at what times will the object have a height of 80 feet? It's going to be at 1 second, and then again at 5 seconds. Alright, so I'll move on to part B. For part B, how long will it take the object to hit the ground? So this is another solving for t, because I'm trying to find a time. In part A, I'm trying to find a time, so I needed to solve for t. In part B, I'm finding how long, which is how many seconds will it take to hit the ground. And what I'm trying to find is the x-coordinate of this point right here. This point, its y-coordinate is 0, which means the object is on the ground, and its x-coordinate is the time that corresponds to when it hits the ground. So I'm going to do a similar algebra. Just like trying to find out when the height is 80 feet, I put 80 in for h and solve for t. To find out when the object hits the ground, I'm trying to find out when the height is 0 feet. I'm going to plug in 0 for the h in the formula and solve for t. This one, it's already set equal to 0, which is nice. I'm going to solve by factoring, and again, I'm going to pull out and divide away my common factor of 16 to make the math easier for me to do. So this is going to give me 0 equals to 6t minus t squared. On the left-hand side, I'm going to pull out a common factor of a t. I'll get 0 equals to t times 6 minus t. And then I'm going to set t equal to 0 and 6 minus t equal to 0. When I set the t equal to 0, I actually get this point right here, which is the point 0, 0. And this is because the object started at the ground. The first answer doesn't answer the question, how long will it take to hit the ground? It says it starts at 0 seconds, it's on the ground. And the next factor, when I set it equal to 0 and add t to both sides, I get 6 equal to t. This point right there is the point 6 comma 0. And it basically has the answer to the question that I'm asked in part B. It's going to take 6 seconds to hit the ground. So for 2B, it will take 6 seconds to hit the ground. I could make this more of a complete sentence, but that's good enough. Part C, determine the maximum height. Well, the maximum height is going to be the y-coordinate of the vertex. The vertex, you can see, is the high point, and so if I can just find the y-coordinate of the vertex, then I'll know what the maximum height is. Because the vertex, the x-coordinate is the time, or any point, the x-coordinate is the time, the y-coordinate is the height. So the maximum height equals the y-coordinate of the vertex. There's a slick way to do this, but that slick way doesn't work for every problem, so I won't do the slick way, although it would be nice probably for you if I did. Let me rewrite this function as h equals negative 16t squared plus 96t. Just writing the negative 16t squared first and the 96t second plus 0. And I'm going to use a formula to get the x-coordinate of the vertex. And then once I have the x-coordinate of the vertex, I'm going to plug it back into the equation to get the y-coordinate of the vertex. So to get the y-coordinate of the vertex, I could do what I did in the last section and do completing the square, because when we did completing the square, we can rewrite the equation of a parabola so that we can pick out the vertex by knowing the transformations left and right and up and down. That's a lot of work, and I don't have to do that. I can get the vertex in steps. So I'm going to get the x-coordinate of the vertex first, and I don't need the x-coordinate of the vertex in my answer, but it's going to help me get the y-coordinate of the vertex, and the y-coordinate of the vertex is what I'm shooting for here. So algebraically, a way to get a vertex when a parabola is written in non-standard form is to use the negative b over 2a formula. That will give me the x-coordinate of the vertex. And in this problem, the a is the number in front of the squared term, so the a is a negative 16. The b is the number in front of the first power term, which is 96. So the x-coordinate of the vertex, which is the time where it reaches the maximum height, is going to be a negative from the formula and the 96 for b, over 2 from the formula and negative 16 for a. This is going to give me negative 96 over negative 32. I think that comes out to be 3, and I'm just going to divide 96 divided by 32, and don't worry about the signs because they cancel, and I get 3. So at 3 seconds, the object reaches its maximum height. To find out the maximum height, I need to find the y-coordinate of the vertex. To get the y-coordinate of the vertex, I just take the 3 and plug it in for the t's into the formula that gives me the height. Do this on my calculator as well. So negative 16 parentheses 3 squared plus 96 parentheses 3. And that gives me 144. And I'll say its maximum height is 144 feet. So the answer to part C is the max height is 144 feet. So now I'm going to flash your problem 1 up on the screen and let you, and kind of talk you through it a little bit, because it's a little bit different. Is it different enough that I should do it with you and maybe skip my number 4? No, maybe not. So when you go to do part 1A, it asks how long does it take to hit the ground. It gives you a formula that's similar to mine. When you do part 1A, you want to find the time where the height is 0, and this x-axis is still a time and the y-axis is still a height. To do part A, you're just going to set 0 equal to the function itself. To do part B, when does it reach its maximum height? Well, the vertex has 2 bits of information. The vertex has the time that it reaches the maximum height, and it has the maximum height. The x-coordinate of the vertex of the parabola that's implied by this function is the time where it reaches its maximum height, and the y-coordinate is the maximum height. Part B just wants me to find when or at what time does it reach its maximum height. For part B, you just need to find the x-coordinate of the vertex, and you can do that using the negative b over 2a formula. For part C, it asks me what the maximum height is, and you can find that by finding the y-coordinate of the vertex. And you find the y-coordinate of the vertex by plugging the x-coordinate of the vertex in for t. So whatever answer you get to part B, you're going to plug in the function for t. That will give you the y-coordinate of the vertex, which is the maximum height. So we're going to plug the x-coordinate of the vertex in for t. I say x, it's really a t, but we kind of think of that more as an x. All right. So I voted to do your problem 3, and it was just a horrible idea. I've done it like 5 times, and to do this problem, you have to use the quadratic formula to get your answer. And this calculator is really, really a horrible calculator to use the quadratic formula for. I have this cheap calculator that if you had me for intermediate algebra, that's lovely for the quadratic formula. I got the problem right every time that I used this calculator. Didn't get it once right when I used this calculator. So let me try to do this correctly this time. So I'm given a function that models a ball being shot in the air. The h is the height in meters. The t is the time in seconds. If you plug 0 in for t, these 2 pieces go away that have the t's, and you get 1.6. And that says that its initial height is 1.6 meters in the air. So the path that this ball follows is it starts off at 1.6 meters in the air, it goes up, and it comes back down and hits the ground. For part A, I want to find out how long will it take to reach a height of 35 meters. So I'm going to find 35 meters on the y-axis and go across and find the 2 points that have a y-coordinate of 35. So what my algebra for part 3A is going to involve is finding the times where the height is 35 meters. There's probably going to be 2 of those times. And to do that, I'm going to put 35 in for the height. So for 3a, to get the times where the height is 35 meters, I'm going to put 35 in for the height, and I'm going to solve for t, and I should get 2 answers. My instructions say round to 2 decimals, and that's a grim instruction, which probably means this is nasty to solve. I'm going to get this set equal to 0 and use the quadratic formula, and I'm going to get 0 on the right hand side. I'm going to add 4.9t squared to both sides. I'm going to minus 30t from both sides, and I'm going to minus 1.6 from both sides. When I do that to the right side, I force everything to cancel out, and I get a 0. On the left-hand side, I have the 4.9t squared minus 30t minus 1.6. No, not minus 1.6. Then I have to combine the 35 minus 1.6. So 35 minus 1.6 is going to be 33.4. So plus 33.4. So I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. The a is going to be the 4.9. The b is going to be my minus 30. And then this blurry 33.4 is going to be my c. So that this is going to give me negative 30 plus or minus the square root of negative 30 squared minus 4 times 4.9 times 33.4 all over 2 times 4.9. This is so hard for me to enter. I'm going to do it in steps. First, I'm going to figure out what that is, which is 30. Then I'm going to figure out what this is. So let me do that real quickly. So I'm going to do parentheses negative 30 squared minus 4 parentheses 4.9 parentheses 33.4. Forgot a parentheses. And under the square root, I get 245.36. So this is going to be 30 plus or minus the square root of 245.36. And the denominator, 2 times 4.9 is 9.8. So I'm going to enter this on my calculator, and that's a lot safer to enter. To enter this on my calculator, I'm going to go parentheses 30 plus the square root of 245.36. That 245.36, my calculator is going to force it to be in a parentheses, and then I'll need to put another parentheses to close out the numerator, and then divide it by 9.8. That'll give me one of the 2 times where the object is at a height of 35 meters. So now on my calculator, parentheses 30 plus second square root, the 245.36 needs to be in a parentheses, the whole numerator needs to be in a parentheses, and then divided by 9.8, and I get I'm going to round that to 66 seconds. Now I'm going to enter the same thing with a minus. So I'm going to go 30 minus second square root 245.36 parentheses divided by 9.8, and I get 1.46 if I round that to 2 decimals. So my answer to part A, how long will it take to reach a height of 35 meters? I'm going to say 1.46 seconds and 4.66 seconds. When I move on to go to do part B, it wants to know how long will it take to land. I need to find this point right here. Its y coordinate is 0. It's when its height is 0, and that's what I'm trying to find out. I'm trying to find out the time when the height is 0. I'm going to do that by the quadratic formula in a second. I do that by putting 0 in for h and solving for t. There's actually going to be 2 times where the height is 0. The second time is going to be a negative time, and it won't be applicable to this. Time only can be positive for these types of word problems. So to do part B of number 3, I'm going to plug 0 in for the height and solve for the time. I'm going to get 2 times. I'm going to want the positive one. I'm going to use the quadratic formula. It's set equal to 0, so I don't have to worry about setting it equal to 0. I'm going to go A equal to negative 4.9, B equal to 30, C equal to 1.6, and go. T equals to negative, and then B is 30. Since the B is positive, it doesn't need to be in a parentheses. And then plus or minus the square root of B squared, which is 30 squared, minus 4 times negative 4.9 for A times 1.6 for C, all over 2 times negative 4.9. And again, I'm going to be safe and do the underside of the square root, which is 30 squared minus 4 times negative 4.9 times 1.6. Keep forgetting that parentheses. Wow. Under the square root, I get 931.36. So I'm going to get negative 30 plus or minus the square root of 931.36. And in the denominator, 2 times negative 4.9 is negative 9.8. So I'm going to try to enter this on my calculator one at a time. First, I'm going to go negative 30, parentheses for the numerator. And the 931.36 needs to be in a parentheses. So I'm going to go parentheses, negative 30 plus second square root, 931.36, parentheses to close out the square root, parentheses to close out the numerator, and then divide it by negative 9.8. And I get negative 0.05 seconds. That's I need to ignore that. And now I'm going to do the next one by going parentheses, negative 30 minus second square root, 931.36, parentheses, divided by negative 9.8. And I get 6.18 seconds if I round that to 2 decimals. So my answer for part B, how long will it take to hit the ground? I'm going to say it's 6.18 seconds. Let me do this real quickly on this calculator to make sure I haven't done anything silly. So negative 30 plus the square root of 931.36 over negative 9.8 is a 6.175. I feel good about that. So my answer is 6.18 seconds feels really good. Unless I made a mistake earlier, and I guess at some point, if I make a mistake, I'll watch the video, I'll see it, and then we'll make a comment. For part C, to determine the maximum height, well, the maximum height is the y-coordinate of the vertex. The x-coordinate of the vertex is the time to get to the max height. The y-coordinate of the vertex is actually the maximum height. So I'm going to find the y-coordinate of the vertex using the formula negative b over 2a, and it takes me stages to do that. So to do part C, first I'm going to find the x-coordinate of the vertex using the formula negative b over 2a. And then I'll find my answer, which is the y-coordinate of the vertex. So the vertex, the equation of the parabola or the function is that right there, where the a is negative 4.9, the b is 30. I'm using the negative b over 2a formula. Negative b is going to be negative 30. 2a is going to be 2 times negative 4.9. I'm going to do that on my calculator. I'm going to go negative 30 divided by parentheses 2 times negative 4.9. And I'm going to write 3.06. So at 3.06 seconds, it's the time that it gets its maximum height. Now I'm going to get the y-coordinate of the vertex. I'm going to go height equals, and I'm going to plug in for those two t's 3.06. So negative 4.9 times 3.06 squared plus 30 times 3.06 plus 1.6. And let me see what that comes out to be. So clear negative 4.9 and then parentheses 3.06 squared plus 30 times 3.06 plus 1.6. And I get 47 point, I'll round to 2 decimals, 5.2. That's the maximum height. I'm supposed to round to 2 decimals and it should be in meters. When I go to answer part C, I'm going to say the maximum height is 47.52 meters. That was just a horrible problem for number 3. Usually I like to work into the disgusting problems, but this one just kind of just came right out with it. All right, so that's number 3. Let me just show this bottom up just in case I didn't show it perfectly. Number 4 is a baby problem by comparison. So a student tosses a water balloon off the roof of an apartment building. The height h in feet of the balloon t seconds after its launch is given by the formula h equals negative 16t squared plus 48t plus 100. How many seconds will it take the balloon to hit to the ground? So basically this is supposed to be the apartment, which I'm going to make the y-axis, and a student takes a balloon and just tosses it off, and eventually it hits the ground, and when it hits the ground, its height is 0. This equation is a similar equation to all the equations we've had so far. The x-axis is the time, the y-axis is the height. The formula is real similar. And we're just trying to find when it hits the ground, we're trying to find the time where the height is 0. So to do part 4, the only part of it, I'm going to set 0 in for the height and solve for the time. This is really nice because I think all these numbers are divisible by 16. So I'm going to divide everything by 16 to make my work easier. To make it even more nice, I'm going to divide by negative 16. Because there's a negative in front of the square term. And I have to do this to the 0 as well, but 0 divided by anything is 0. On the right-hand side, the first division gives me just a t squared. The second division, when I go 48 divided by negative 16, I get negative 3. So this is going to give me a minus 3t. The last division, when I do 112 divided by negative 16, I get negative 7. Really? Wow. I've just been horrible to myself here. So this equation needs to be solved, and unfortunately that doesn't factor, so I'm going to use the quadratic formula. I'm going to use a equal to 1, b equal to negative 3, c equal to negative 7, and I'm going to go t equals negative b, which is negative 3, plus or minus the square root of negative 3 squared minus 4 times 1 times negative 7 for the 4ac, all over 2a, which is going to be 2 times 1. And before I pull out my calculator, I'm going to simplify a little bit. The double negative 3, I'm going to make a positive 3. And under the radical, I'm going to figure out what that equals to by going parentheses negative 3 squared minus 4 parentheses 1 parentheses negative 7. Under the radical, I'm going to get 37. And in the denominator, I'm going to get 2. When I go to enter this on my calculator, the 37 is going to need to be in a parentheses, and the numerator is going to need to be in a parentheses. So I need lots of parentheses. So to enter this, parentheses 3 plus second square root, 37 goes in a parentheses, close out the parentheses for the numerator, divided by 2, and I get 4.54 seconds. Let me do the one with the minus by going 3 minus second square root 37 parentheses parentheses divided by 2, and I get negative 1.54 seconds, which I can't accept the negative time. So my answer for this is going to be at 4.54 seconds, the balloon's going to hit the ground. So my answer is going to be at 4.54 seconds. All right, let me flash up your problem 3.5, which is kind of the same problem. So give it a go. I think your numbers are going to be better than mine, but I'm not confident in that. Problem 6 and 7 I snuck on the same page. Both of ours are the same problem. It talks about a similar problem anyways. It talks about a diver jumping off a cliff into the water that's 240 feet below. And the picture for problem 6, this would kind of be the cliff. The y-axis will be the cliff. And the jumper goes down, follows a path that looks something like that, hits the ground, or hits the water. And the x-axis again is the time, the y-axis again is the height, and the question is how long does the dive last? I'm going to assume the dive stops when he hits the water, even though he probably goes under the water and comes back up. But what I'm going to do in problem 6 and what you're supposed to do in problem 7 is you're supposed to find the time where the height is 0, and that's how long the dive lasts. To do that, I'm just going to plug 0 in for the height and solve for time. I think I can divide all this by negative 16 to make my numbers easier. At least I hope I can. 0 divided by negative 16 is 0. Negative 16 divided by negative 16 is 1. We'll leave them with a t squared. And then 240 divided by negative 16 is negative 15. My Lord. So I get t squared minus 15 equals to 0. This is a really nasty section. I don't know what I was thinking when I wrote it. So now I'm going to solve by square rooting because that doesn't factor and it's not really set up for the quadratic formula because there's not a t to the first power term. So I'm setting it equal to 0 and I'm going to go plus or minus square root, and I'm going to get t equals plus or minus the square root of 15, and the square root of 15 is 3.87. So the algebra says that it takes plus or minus 3.87 seconds to hit the water. Obviously I need the positive answer, so my answer is going to be 3.87 seconds it'll take to hit the ground. So your problem 7 should work similarly. Hopefully the numbers are a little bit nicer. Alright, so 8 and 9. 8 and 9 talk about a store manager, or 8 talks about a store manager, and the main office gives them a profit function that relates to the number of clerks working. So in some sense, if you don't have any clerks at a store, you're probably not going to be able to sell anything, so you're not going to make any profit. If you had like 1,000 clerks, well, at some point there's going to be clerks not doing anything, so you're going to be paying them for doing nothing, and they're not going to help you produce profit. But if you have enough clerks walking around the aisles, maybe they can encourage people to buy stuff, advise them, or they can keep the store clean and stocked, and you're going to sell more. So maybe there's an optimum number of clerks for this chain store. And this equation says for this store, if you give me a value for x, which is the number of clerks, I can tell you the profit. So the function is going to graph to be a parabola. The x-axis is the number of clerks. The y-axis is the profit based on that number of clerks. And this is another parabola. It's going to graph as a parabola that opens down, and the vertex is somehow going to be the maximum point. The x-coordinate of the vertex is the number of clerks that will lead to the maximum profit. The y-coordinate of the vertex is the actual maximum profit. So to do question 8, I'm really just trying to find the vertex. Part 8a wants the x-coordinate of the vertex. Part 8b wants the y-coordinate of the vertex. To get the x-coordinate of the vertex, I'm going to use the negative b over 2a formula, where the a is a negative 25, and the b is 300. So using the negative b over 2a formula will get me the x-coordinate of the vertex. I'm going to do that by going negative 300 over 2 times negative 25. So now on my calculator, negative 300 divided by parentheses 2 times negative 25, and I get 6 clerks. So the answer to part A, the optimal number of clerks for this chain store is 6. And to find the maximum possible profit, I'm going to take the 6 and plug it in for the x's. That will give me the y-coordinate of the vertex. I'm going to go negative 25 times 6 squared plus 300 times 6, and that will give me the profit that corresponds to that many clerks. So negative 25 times parentheses 6 squared plus 300 parentheses 6, and it's going to be $900. I guess maybe that's a daily profit, I hope. So daily profit. So the max profit per day is going to be $900. So a really friendly problem compared to the last couple. Your problem 9 is real similar. We're given a profit function written in function notation as opposed to just using the letter P. And this is going to give me the weekly profit based on the number of items that are sold. So in some sense, if you sell too many items, then maybe the cost starts to go up because you've gotten all the items at the cheap price that you can, and you have to start paying more for them. So there's an optimal number of items. Maybe to sell 1 million items, you've got to hire so many more employees that it doesn't become profitable. So the function that's given in yours is similar to the function in my number 8. It's a parabola. The x-coordinate is going to be the number of items that you sell in a week. The y-coordinate is going to be the profit. This is a parabola that opens down. It's really negative 1x squared plus 50x. You're trying to find the number of units that will maximize the profit and what the maximum profit is. The x-coordinate of the vertex is going to be the number of units that maximize profit. And the y-coordinate of the vertex is actually going to be the maximum profit. So when you go to do part 9a, you're going to find the x-coordinate of the vertex by using the negative b over 2a formula. When you go to do part 9b, you're going to take your answer to part A and plug it into the formula, and you'll get the maximum profit. All right. 10 and 11 are... I voted to do your number 11 instead of my problem 10. I don't generally ask this on the test, so just to help you through your homework. So a manufacturer of lighting fixtures has daily production costs of C of x equals that ugly formula where x is the number of units produced. And then I'm asked how many fixtures should be produced each day to minimize costs and what is the minimum cost. So this function, if I go to graph it, the x is the number of lighting fixtures produced. So it's a number of whatever we're making, lighting fixtures produced in a day. And the y is the cost of producing that many lighting fixtures. This thing will graph to be a parabola, and it doesn't open upside down. It opens with the vertex at the bottom because there's a positive in front of the x squared. So the graph is going to look something like this. It doesn't matter exactly what the graph looks like, but I should know that each point, the x-coordinate is the number of fixtures produced, the y-coordinate is the cost. Because I want to get the minimum cost, I want the point at the bottom of the parabola, which is the vertex. The vertex will have the information I need. The vertex, the x-coordinate, will be the number of units to produce to minimize cost. And the y is going to be the actual minimum cost. So let me go ahead and find the vertex, and that will answer my questions A and B. For part B, the number of fixtures to minimize cost is the x-coordinate of the vertex, which I'm going to get by using the negative b over 2a formula. The b is negative 10. I'm going to go negative b, which is negative 10, over 2a, which is 2 times 0.25. That's going to be 10 over, whatever. It's going to be 10 divided by 2 times 0.25, whole denominator in a parentheses. So this is going to be 20. So it's 10 over 2 times 0.25. So the answer to part A for number 11, it's going to be 20 units of production will minimize the cost. What is the minimum cost? I just plugged 20 in for these x's, so I'm going to do C of 20 equals 0.25 times 20 squared minus 10 times 20 plus 800. That's going to give me the y coordinate of the vertex, which is the minimum cost. I should round to 2 decimals. So clear. And now 0.25 times 20 squared minus 10 times 20 plus 800 gives me $700. So the answer to part B, the minimum cost that this company has is $700. Oh, right. So I only have a few problems left, and I do put them on the test. But I'm going to put them in a part 2. It'll be a short part 2.